So now I'm continuing with the Modtran model looking at ozone instead of CO2. So go ahead and turn carbon dioxide off, wait for the model to recalculate. And now let's go ahead and look at the ozone, stratospheric ozone. So we want to get up where we've got, so this is current climate. We're looking at mixing ratios of about 9 parts per million, peaking at about 35 kilometers. So let's go to 40 kilometers again to be above the majority of the ozone. We're looking down and go ahead and increase the ozone mixing ratio to 4 times current and see if we can find a mixing ratio that actually causes the temperatures not to change. So if I go from 8 to 10 times current, for example, it's not seeing very much movement, which means I'm pretty much sure that I'm black here. And so this then is the temperature of the ozone that's emitting the photons that actually make it to me at 40 kilometers. It's 240 degrees. And if I look at the temperature profile and just ask where are those photons coming from, then they're coming from about 5 kilometers below the camera. In contrast to CO2 though, as we mentioned in class, this spike right here is not an absorbing spike, it's actually transparent, and so we're looking further down in the atmosphere. What temperature probably, so between 260 and 280, so call it 270, and so from 40 kilometers then we're seeing down for photons that actually are coming from quite near the surface, altitudes of about 5 kilometers. And again, if we go lower in the atmosphere, so what happens if we actually move our sensor below the stratosphere, so down to 20 kilometers, then the effect of the ozone absorption should just disappear. So at 20 kilometers looking down, if we go back to current climate, where we've now got a band that's actually not very strongly absorbing and is looking at photons that are coming in the transmission spike here quite close to the surface. If we go down further, so well below any kind of stratospheric ozone, now ozone's just not there to do anything, and so we've got the black body back again. But again, just like CO2, if we have have something that is able to remote sense in this wavelength band above the ozone layer, then we'll be able to get temperatures of the middle of the stratosphere. If we look in these absorbing wings and temperatures close to the surface, if we look at this